Hello, my dear students. Welcome you all to Sri Jaindra Rag Zone classes. I am your mentor and your friend for the subject chemistry, and I will be taking the organic chemistry. My dear students, I am going to start with the chemicals which are required in food industries and food supplements. There are many chemicals which are added to food for their preservation, mean food preservatives. Food preservatives help to increase the shelf life of food products. They also act as food additives to enhance the aesthetics or the appeal of food products. They can be of many types. Depending upon their function. First is flavoring agents and sweetening agents. Second, they also provide color in food colors or edible colors. They are dyes, different types of dyes, coloring agents. Then emulsifiers, the skimmed milk we get, that is because of these emulsifiers. Stabilizing agents, which basically avoid the froth formation in the cane foods or the liquid materials containing oils. They can come across the rancidity, and that is why these stabilizing agents help to protect them. Flour improvers, anti-stalling agents, and bleaches. Bleaches is to remove the dirt and stain, provide white color. Okay. Anti-stalling agents, which basically helps the mixing of flour with water so that bead formation could not take place. Okay. So they helps to break the beads formation. Okay. Chunks of material. Then antioxidants, preservatives, and the last is nutritional supplements. These are the main purposes that why these chemicals are used. Okay. Nutritional supplements such as vitamins, minerals, amino acids. Okay. Except nutritional supplements, no other food additive is of nutritional value. Okay. Now, first we will talk about the food preservatives. They are the chemical substances added to the food materials to prevent their spoilage and to retain their nutritional value. Retain their nutritional value. Okay, for long periods. Understood? These preservatives prevent the rancidity of food and inhibit the growth or kill the microorganisms. Microorganisms, right? So, rancidity is basically the food materials having food that oil, okay, or fat. That fat, it can be saturated or unsaturated, that undergoes microbial degradation, it undergoes the natural oxidation, and because of this the product, it becomes unhealthy for edible purposes. Okay, the rancid product comes up with foul smell and altered taste, and that is why a person cannot take it. Okay, so these materials, they prevent the rancidity of food. Okay, by inhibiting the growth of the microbial colonies or killing them. Now, salt, sugar, oils, and spices, in presence of salt, sugar, oil, and spices in a medium in required concentration also act as food preservatives. and I should say high concentrations. High concentrations. Okay? Salt and sugar, they itself act as a preservative but in high concentrations. Understood? Salt and sugar, they make solution hypertonic, which could lead to plasmolysis of bacterial cells. Understood? There are some chemical substances which are synthetically prepared to be added as a food preservatives, like sodium benzoate. Okay, it acts as a preservative. It can be used safely in limited amounts and is metabolized by conversion to hippuric acid, which is a excretory waste. Understood? Then salts of propionic acid and sorbic acid. They are used as preservatives for controlling the growth of yeast and molds, fungi, in food items. Okay, such as meat, fish, pickles, cheese. Okay, sodium and potassium metasulfides used in preservation of jams. Okay, squashes, etc. Butylated hydroxyanisole, BHA, and butylated hydroxytoluene, BHT, are food preservatives for edible oils. They also act as antioxidants. Okay. Now, these are the food preservatives, okay, especially the butylated hydroxyanisole and butylated hydroxytoluene. Along as a food preservative, they also act as what? The antioxidants. Understood? Then sodium and potassium metasulfide, sodium and potassium propionic acid, and sorbic acid. Okay, sodium benzoate. Now comes antioxidants. They are the substances which prevent or retard the oxidative deterioration of food. Okay, so these are the substances which prevent or retard the oxidative deterioration of food. These are antioxidants, especially the substances like fats, oils. Okay, they undergo rancidity. They are added with antioxidants to prevent them from rancidity. From rancidity. Okay, understood? Addition of antioxidants helps to increase the shelf life when you can store more duration. Storage can be done for more duration. Okay, understood? So these are the antioxidants. Okay, the antioxidants, they are sacrificial materials. Okay, they are more reactive towards oxidation, and they prevent or suppress the oxidation of food materials. Okay, now BHT, butylated hydroxytoluene. Okay, it also acts as a antioxidant, as I have already told you. Okay, during oxidation or hyperoxidation, free radicals are generated, and antioxidants, they stop the formation of free radicals. Understood? Now, butylated hydroxyanisole it is used as antioxidant, used for butter, cereals, chewing gum, snack foods, baked food, beer, dehydrated potatoes. Added to butter, dehydrated potatoes. Okay, snack foods, meat, etc. Okay, also used in petroleum industries to prevent the petroleum products. Okay, now sometimes it is added with citric acid for synergistic mean more action, powerful action, synergistic action. Okay, sulfur dioxide and sulfide, SO3 2 minus. Okay, so these sulfides and sulfur dioxide they are used as antioxidants like sodium sulfide. Okay, for their versatile versatile nature, vers- versatile nature means they can be used and effective against wide range of compounds. Okay, so sulfide and sulfur dioxide they are having very efficient working and they are versatile too. They are active as antimicrobial agents. Okay, and they are antioxidants as well, enzyme inhibitors as well. So sulfides and bisulfides. Then artificial sweetening agents, chemical substances. These are the chemical substances which give sweetening effect, which give sweetening effect. Okay, so these are the chemical substances which give sweetening effect to the food and enhance its odor and flavor. Okay. Natural sweetening agents are sucrose, lactose, lactose is milk sugar. Okay. Honey means saccharides. They are the natural sweetening agents. Artificial sweetening agents like saccharine, which is orthosulfobenzamide. Sulfobenzamide. Okay, it is a popular sweetening agent. It's very sweet in taste. 550 times more sweet than sucrose. Okay, it is excreted as such to urine. I mean, it is not going to metabolize in our body. It is not going to provide any harm to the body. Okay. Saccharine is a type of lifesaver drug for diabetes mellitus. It is high blood sugar level. Okay. The calories in saccharine are lesser than sucrose or table sugar. Okay. Sodium salt of saccharine is water soluble. Sodium salt of saccharine is water soluble salt. Water soluble salt. Okay. Other artificial sweeteners are aspartame, elitame, sucralose, okay, dihydrochalcones, DHC, they all are artificial sweetening agents. Aspartame, most widely used, okay, 100 times more sweet than sucrose. It is a methylated ester. Okay. For dipeptide, which is derived from aspartic acid and phenylalanine. Okay. It is unstable at room temperature, cooking temperature. I mean, it is not very much bio uh, thermo thermostable. Okay. It is unstable at cooking temperature. That is why it is mixed to best suited for cold foods and soft drinks. Okay. Now, elitame, which is more stable than aspartame. Aspartame during cooking. Okay. Now, sucralose is a trichloro-derivative of sucrose. Sucralose is a trichloro-derivative of sucrose. Okay. The sweetening index of aspartame, or the sweetening value of aspartame in comparison to cane sugar is, I'll write down. Okay. The sweetening values. So sucralose is the trichloro-derivative of sucrose. Okay. Its taste and appearance is similar to sugar and stable at cooking temperature. Stable at cooking temperature. Okay. Appearance and taste similar to sugar. Okay. It does not provide calories. Okay. So aspartame, the sweetening index in comparison to cane sugar is 180. Elitame is 2000. So it is very difficult to control the sweetening effect. Then sucralose 650. Okay. Dulcin 500. So these are the different sweetening agents Okay, the artificial sweeteners, they are low calorie sweeteners or calorie free sweeteners. Okay, now calcium, cyclamate is used as a calorie free sweetener, but it is banned in UK, banned in USA, as it is suspected to cause cancer. Sucralose is used widely. Okay, these are the food preservatives, sweetening agents. Now we are going to discuss the last topic of this chapter, the cleansing agents. Okay, basically in cleansing agents we have to discuss about soaps and detergents. Okay, because soaps and detergents, they are the substances which are used for cleaning. Okay, soaps, they are sodium or potassium salts of long chain esters of fatty acids. The soaps, they are the sodium or potassium salts of long chain esters of fatty acids. Okay, detergents, they are sodium or potassium, mainly potassium salts of long chain esters of sulfonic acids. Okay, some common examples of soaps are like soap of palmitic acid, which is C15H31COOH. Okay, so these are some common fatty acids which are used. Okay, like palmitic acid, it forms sodium palmitate. Sodium palmitate. Okay, stearic acid, C17H35COONA, sodium stearate, and like this. Okay, now, okay, sodium and potassium salts of these higher fatty acids, they make soaps like sodium palmitate, stearate, I have already discussed. Soaps, they are prepared, they contain animal fats or vegetable oils. They contain either animal fats or they contain vegetable. Fats and oils are esters of higher fatty acids and glycerol. Fats and oils are esters of glycerol and higher and long chain fatty acids. Okay, they are known as what? Glycerides. Okay, when oils and fats, that is glycerides, they are heated with a solution of sodium hydroxide when saponification reaction undergoes saponification. Okay, like it is so. Okay, NaCl is added to separate the soap colloids. Okay, it decreases the solubility of soap in water. Okay, as soap is lighter than water, it floats on the surface of water. Being lighter, it floats on the surface of the water. Okay, types. One more thing. These soaps are added. They are added with different types of colors, perfumes, okay, and chemicals of different medium. Okay, types of soap. First is the toilet soaps. They include better grades of oils and fats. Okay, better grades of oils and fats. Okay, excess alkali is removed. removal of excess alkali in these toilet soaps. So these soaps are they are free from excess alkali and form more leather formation. Okay, when whenever they mix with water, they have higher solubility and they make leather. झाग बनेगा. Okay, medicated soaps, they are soft, containing compounds of medicinal importance like biethanol. Okay, then shaving soaps, they are potassium sodium stearates. Okay, plus glycerol, they contain glycerol for rapid drying. Okay, they also contain rosin. Okay, to make more leather. Then laundry soaps, transparent soaps, transparent soaps. Okay, they contains ethanol. Okay, to make them transparent. Okay, how these soaps perform their cleansing action. Soaps are 100% biodegradable. Biodegradable. Okay, they don't do not cause biomagnification, and they cannot pass from one trophic level to the other trophic level in a food chain. Okay, so they do not cause biomagnification as the detergents can do. Okay, then soaps cannot be used in hard water as hard water basically contains salts of calcium and magnesium, either bicarbonates or sulfates or chlorides. Okay, whether it is a permanent hardness, whether it is a temporary hardness. Okay, this is soap when it combines with the magnesium. Okay, of magnesium chloride or magnesium sulfate. Okay, so this magnesium from hard water it make a insoluble insoluble scum. Hold twice mg. Okay, this is scum, insoluble precipitate. And therefore there will be no lather formation. Okay, and the cleansing action of soap basically is not accomplished. Okay, these precipitates, they stick to the fibers of the cloth as a mass, gummy mass chunks. Okay, and blocks the ability of soap to remove oil and grease from the fabric. Okay, it interferes with the cleansing action of soaps. Understood? The cleansing action of soap is being briefly described in the chapter surface chemistry. Okay. Now, soaps, they cannot be used in acidic media because they undergo neutralization reaction free fatty acids with the formation of precipitate, which also stick to the fabric. Okay. So to overcome all these problems, synthetic detergents, or we can say soapless soap, are used. They are known as soapless soaps because they behave like soaps but do not contain sodium salts of fatty acids. Of fatty acids. They are better cleansing agents because they can work both in hard water and soft water. Hard water and soft water. Okay. Now, there are different types of these synthetic detergents. Okay. First, sodium salt of long chain benzene sulfonic acid. Example, what you have to remember, para-dodecyl benzene sulfonate. Okay. sulfonates mean this para-dodecyl benzene sulfonate or the other sulfonates with when mixed with triethanol ammonium ion in place of sodium in place of Na plus. Okay, they become the highly soluble material for liquid soap. So liquid soap basically contains what? Triethanol ammonium ion. Okay, C12H25. This is benzene sulfonate. Then CH2, CH2, OH, thrice. This is triethanol ammonium ion for liquid detergents. Okay, understood? Then there can be sodium salts of long chain alkyl hydrogen sulfate. Second category is sodium salt of long chain alkyl hydrogen sulfates. So they can be salts of either sulfonates or they can be the sodium salts of long chain alkyl hydrogen sulfate. Example, sodium dodecyl sulfate. Now it is not sulfonate, it is sulfate. Okay, or sodium cetyl sulfate. C16H35 COO. Sorry, not CO. It is not carboxylic acid, sulfonic acid. OSO3 Na plus. Okay, sodium cetyl sulfate. Okay, sodium dodecyl sulfate is also known as sodium lauryl sulfate. Sulfate. Now, the classification of detergents. First is anionic, second cationic, and the third is non-ionic. These are three types: cationic, anionic, and non-ionic. This classification is basically based on the nature of surface active group. The above classification is based on surface, which type of active group is present on the surface group. It is present on the basis of surface active group. Okay, anionic detergents, as the name suggests, the anionic detergents they contain anionic group, hydrophilic group. So they mainly contain anionic hydrophilic group. Okay, they are manufactured from long chain alcohols. From long chain alcohols. They are manufactured from long chain alcohols. The long chain alcohols are treated with concentrated sulfuric acid to form alkyl hydrogen sulfates. Okay, they have high molecular mass. Okay, like for example, CH3, CH2 whole 10, OSO3 minus Na plus. This is an anionic detergent. Okay, L'Oreal alcohol is used to is neutralized by H2SO4 to form sodium lauryl sulfonate. Okay, same thing is for dodecyl benzene sulfonic acid, which undergoes saponification to form sodium dodecyl benzene sulfonate. So I'll write the examples. Sodium dodecyl benzene sulfonates. All are okay. It is a anionic detergent. Then sodium dodecyl sulfate is also a anionic detergent. In anionic detergents, sorry, the anionic part is involved in cleansing action. The anionic part is involved in cleansing action. Okay. Alkyl benzene sulfonate, as I have already discussed, they are the most common. Alkyl benzene sulfonate. They are the most common anionic detergents. Okay. They can be used in acidic solutions as well. That is why they are considered to be more superior than soaps. They can be used in slightly acidic solutions as well. Okay. And they are used in toothpaste. So they are used in toothpaste. Next category is cationic detergents. They mainly contain quaternary ammonium salts of amines. They mainly contain quaternary ammonium salts, okay, of amines with acetates, chlorides, etc. Okay. They contain the cationic part, okay, which is basically having a long chain hydrocarbon chain with a positive charge on nitrogen atom, like okay. So this is the cationic part. You can see the cetyl trimethyl ammonium bromide, cetyl trimethyl ammonium bromide. Example. Okay. The cationic detergents are more expensive than anionic detergents and they contain germicidal properties. Germicidal and more expensive. Okay. Then comes non-ionic detergents. They do not contain any ion. In their constitution, like the esters of higher molecular mass. They do not contain any ion in their molecular formula. Their molecule. Okay. Then they contain polar groups present which can form hydrogen bonds with water. So polar groups are present which can form hydrogen bonds with water. Okay. And they are obtained by polyethylene glycol and stearic acid. Okay. Liquid dishwashing detergents are non-ionic. Are non-ionic. Okay. So liquid dishwashing detergents are non-ionic in nature. Synthetic detergents, they are non-biodegradable, so they can cause bioaccumulation. Okay. They can cause disturbance in the food chain. Disadvantages of synthetic detergents. Non-biodegradable. can get accumulated in our food chain and cause toxicity. Okay, can lead to overgrowth of algae, algal blooms in surface of stagnant water bodies, can get covered by the layer of algae, and there are many more disadvantages. Okay, can increase the biochemical oxygen demand of, okay, can increase the biochemical oxygen demand of organisms living in water. Okay, so synthetic detergents, they have different, they can be of, these are the disadvantages of synthetic detergents and many more disadvantages. Okay, that is why to solve this problem, we are using or try to using the concept of minimum branching of detergents, of hydrocarbons involved in detergents to make detergents. Okay, to make them biodegradable. Understood? So these are soaps and detergents I have discussed. The cleansing action of soap and detergents I am not discussing because that part is already covered in the chapter of surface chemistry. Okay, the cleansing action of soaps and detergents. Okay, so my dear students, till then, bye bye, take care, stay safe, stay healthy.